Dear all, I am continuing with an example of even and odd signal. So here you are given a signal x of t in its graphical representation like this. Okay, so this is the given signal x of t. So you know that for finding the even component of the signal, I need to apply the equation x of t minus plus x of minus t by 2. So I need to take x of minus t. So since x of t is in graphical notation, I can draw the graphical notation of x of minus t also. So how I can draw is take the mirror image about y-axis. So this is my y-axis. This is my y-axis. Take the mirror image about y-axis. So if I am taking the mirror image about y-axis, the right hand side of the figure will be moving towards left hand side and left hand side of the figure will be moving towards right hand side. So I will be getting a figure like this. So this is actually x of minus t. Okay, now I am going to take x of minus t. Minus of x of minus t is actually obtained by multiplying x of minus t, that is this x of minus t with a quantity equal to minus 1. Okay, so if I multiply my x of minus t with minus 1, I will be getting minus of x of minus t. So if I am multiplying this particular signal with minus 1, that will be equivalent to what? Positives, all positive will be moving to negative side and negatives will be moving to positive side. So here it is moving from, you will be having an amplitude 1 from minus 2 to 1, minus 1, and an amplitude 2 from minus 1 to 0. So if you are multiplying it with minus 1, then I will be getting from minus 1 2 to minus 1, I will be getting minus 1 as amplitude, and from minus 1 to 0 I will be getting minus 2 as amplitude. So I will be getting a signal like this. Okay, so similarly you can find the negative of the right hand side also. Here it is moving from 1 to 0, so the reverse is, here it is moving from minus 1 to 0, because since we are multiplying the signal with minus 1. Now what about this interval from 1 to 2 is the amplitude is maintaining constant at minus 1. So here minus 1 into minus 1 will give you plus 1 as the amplitude. So this is what minus of x of minus t. Now first of all I am going to find the even signal, that is equal to x of t plus x of minus t by 2 given by this equation. So in order to take the sum, I need to consider the interval wise. Okay, so first I am going to consider the interval minus 2 to minus 1. Here the amplitude is 1 and here the amplitude is what? Minus 1. So minus 1 plus 1 will give you what? 0. So I will be getting an amplitude 0 at the output. So output from minus 2 to minus 1 is 0. Okay. Now take the next interval minus 1 to 0. Then in minus 1 to 0, x of t is varying from 0 to 1. Okay, from minus 1 to 0, what is the variation of x of t? X of t is that x of t is varying from what? 0 to 1. And x of minus t is varying from 1 to 1. So what will be the final amplitude? So from I am repeating, from minus 1 to 0, x of t is varying from 0 to 1 and x of minus t is varying from 2 to 2, not from 1 to 1, it is varying from 2 to 2. So if I am taking the sum will be what? 2 here, the sum will be 3 here, and you have to take the sum divided by 2. So what is the variation of the sum x e of t is what? The x of t is varying from 2 by 2 1 to 3 by 2 1.5. So that is why I am getting a portion like this. The amplitude is varying from 1 to 1.5. Okay. Now I need to consider the next interval, that is from 0 to 1. 0 to 1, what is the case with x of t is from 0 to 1, my x of t is varying from where to where? My x of t is varying from 2 to 2. That means the amplitude is 2. So my x of t is varying from 2 to 2. Then from the same interval, I am having my x of minus t, that is varying from 1 to 0. So here it is varying from 1 to 0. So what is the sum divided by 2 is, here you are getting amplitude from 3 to 2. So x e of t at that particular moment will be what? 3 to 2 by 2. That means it is varying from 1.5 to 1. That means here it is varying from 1.5 to 1. Then what happens to the next interval is that from 1 to 2. So here I have 2 sets. Then the third stage is from 1 to 2. What happens from 1 to 2? 1 to 2, my x of t is varying from where to where? X of t is varying from 1 to 1 itself. So x of t is varying from 1 to 1. Then the same interval, what happens to x of minus t is that x of minus t is varying from where to where? It is varying from minus 1 to minus 1. So if I am taking, it is varying from 0 to 0 by 2. Okay, therefore I am getting my final amplitude at that interval as 0. So this is the original signal, or this is the even component of the original signal. Okay, now we have to study we have to find the odd component of the signal. So odd component, what is odd component is that it is equal to x of t plus x of minus t by 2. Okay, x of t plus x of minus t by 2. So if I am considering, this is my x of t. X of t is what? X of t is given by the first figure. So now x of t is given by the first figure. This is x of t, and x of minus t is this. Okay, I need to take the sum of this signal with this signal. Okay, so what is the case is, here also you have to consider interval wise. First of all, you are considering minus 2 to minus 1. So what happens from minus 2 to minus 1? Minus 2 to minus 1, my x of t is varying from where to where? X of t is varying from minus 1 to minus 1. There is no change. X of t is varying from minus 1 to minus 1. Then the same interval, what happens to minus of x of minus t? Minus of x of minus t is varying from where to where? It is varying from, again it is varying from minus 1 to 1. Okay, so it is varying from minus 1 to minus 1. Now if I am taking the sum, it will be varying from minus 2 to minus 2. Sum with divided by 2 will give you the output. So my output will be varying from where to where? The output should vary from the output that is in the interval minus 2 to minus 1 should be varying from what? Where to where? It is varying from minus 1 to minus 1. Okay, so this will be the output. Then what happens to the next interval is from 1 to 2. From 1 to 0. Minus 1 to 0. From minus 1 to 0, my x of t is varying from where to where? It is varying from 0 to 1. So this is the portion corresponding to that. I have minus 1 to 0 interval. Here it is varying from 0 to 1. Then what happens the same interval for x of minus t? Minus of x of minus t. In that case, that means minus of x of minus t in the same interval from minus 1 to 0, it is varying from where to where? Minus 2 to 2. So here it is varying from minus 2 to minus 2. If I am taking the sum of this, it will be varying from minus 2 to minus 1 divided by 2. That means it is varying from minus 1 to minus 1.5 or minus 0.5. So now if consider this point is minus 0.5. So my amplitude is varying from minus 1 to minus 0.5. Okay, so this is the case with the interval 0 to minus 1 to 0. Now consider the interval from 0 to 1. What happens to 0 to 1 is that from 0 to 1, my x of t is varying from where to where? X of t is varying from 2 to 2. That means x of t is maintaining at amplitude 2, and minus of x of minus t, what is happening is minus of x of minus t is varying from minus 1 to 0. Okay, so here it is varying from minus 1 to 0. So if I am taking the sum, this will be 1 to 2 that divided by 2. That means what? It is varying from 0.5 to 1. That means suppose if here it is, if you are having the amplitude 0.5 and here it is 1, then it is varying from 1.5 to 1. So this is the shape in that particular interval. Okay, now consider the next interval that is varying from where to where? It is varying from 1 to 2. 1 to 2, what is happening is, what is the amplitude of x of t is, x of t is maintaining a constant amplitude from 1 to 1. That means here x of t is having the amplitude 1 to 1. What happens to minus of x of minus t is that minus of x of minus t is varying from where to where? It is also varying from 1 to 1. That means here that is also varying from 1 to 1. So if I am taking the sum, the sum will be varying from 2 to 2. If I am dividing by 2, it will be 1 to 1. That means here I am getting the amplitude at 1. Maintained at 1. From which interval to which interval? From 1 to 2. So this will be the odd component of the signal. Okay, so now I am having my odd component given by this figure and even component given by this figure. So I am having odd and even component. So this is how you need to consider the even and odd component if you are given the graphical representation of the original signal. Okay, thank you.